Welcome to the Flat Roof Systems training session. In this video, we'll cover everything you need to know to confidently discuss low-slope roofing systems with your clients, from the materials and installation methods to the insulation, accessories, and building code requirements specific to the St. Louis area. Thermoplastic polyolefin, TPO, is one of the most popular commercial flat roofing systems in the St. Louis area. It's a single-ply, white reflective membrane that's energy efficient and helps reduce cooling costs during hot Midwest summers. TPO roofing offers several advantages for property owners in Missouri. It is highly UV resistant, meaning it can withstand prolonged exposure to sunlight without degrading, which helps extend the life of the roof. The material is flexible, allowing it to expand and contract with temperature changes, and it is highly reflective, reducing heat absorption and helping lower cooling costs during hot summer months. However, TPO does have some potential drawbacks. If it is not properly welded or maintained, the membrane can shrink or split over time, particularly during the freeze-thaw cycles common in Missouri's climate. Regular inspections and quality installation are essential to avoid these issues and ensure the system's long-term performance. EPDM is a black rubber membrane known for its durability and flexibility. It performs well in St. Louis' wide seasonal temperature swings. EPDM roofing is known for its exceptional resistance to UV radiation and ozone, making it one of the most durable and weather-tolerant flat roof materials on the market. Its rubber composition provides excellent long-term waterproofing, ensuring dependable protection against leaks and moisture intrusion for many years. However, because EPDM is typically dark in color, it tends to absorb more heat from the sun. This can increase indoor temperatures and raise cooling costs during warmer months, especially in regions like Missouri with hot summers. To counteract this, many installers recommend using reflective coatings or ballast systems to improve energy efficiency and reduce heat absorption. Modified bitumen is a time-tested roofing system made up of two primary layers, a base sheet and a cap sheet. It can be installed using torch-down, cold adhesive, or self-adhered methods. Modified bitumen roofing is extremely durable and highly puncture-resistant, making it an excellent choice for smaller commercial buildings and residential low-slope roofs. Its multi-layer design provides exceptional strength and flexibility, helping it withstand foot traffic, hail, and seasonal temperature changes. However, installation can be labor-intensive, often requiring skilled crews and more time on site compared to single-ply systems. In the case of torch-down applications, the process also demands strict fire safety precautions to protect both workers and the property, which adds to the overall complexity of the installation. Polyvinyl chloride, PVC roofs are similar to TPO but offer greater chemical resistance, perfect for restaurants, factories, or buildings where grease or chemical exposure may occur. Its excellent weldability allows installers to create strong, watertight seams that enhance long-term performance and leak protection. While PVC offers outstanding durability and energy efficiency, it can become brittle with age, especially after long-term exposure to extreme temperatures. Additionally, it tends to be more expensive upfront than TPO or EPDM systems, though its longevity and chemical resistance often justify the higher initial investment. The traditional built-up roof uses multiple layers of asphalt and felt, topped with gravel or reflective coatings. Built-up roofing, BUR, systems provide excellent multi-layer protection that delivers long-lasting waterproofing and superior durability. Their layered design makes them highly resistant to foot traffic, making them ideal for commercial buildings that require frequent rooftop access for maintenance or equipment servicing. However, BUR systems are also heavier than most modern single-ply membranes, meaning they require strong structural support to bear the added weight. Additionally, installation can be messy and time-consuming, involving hot asphalt or tar and multiple layers of felt or fabric, which demands experienced crews and careful handling to ensure proper application. There are three main installation techniques involved with these types of flat roof systems, and they differ in their level of complexity, retail price, and final appearance. 1. Fully adhered. The membrane is glued directly to the insulation or cover board using adhesive. Fully adhered flat roof systems provide a smooth, clean finish and offer excellent resistance to wind uplift, making them a preferred choice for buildings in areas with strong storms or variable weather conditions. However, these systems can be more costly to install due to the price of adhesives, and the cure time required for bonding can extend overall labor time compared to mechanically fastened installations. TPO, EPDM, PVC, and modified bitumen roof system can all be installed with a fully adhered technique and execution. 2. Mechanically fastened. Sheets are secured using screws and plates along the seams. Mechanically fastened flat roof systems offer faster installation and lower material costs since they don't require adhesives, making them an efficient and economical choice for many commercial projects. However, they can be more susceptible to wind uplift around fasteners and thermal bridging at the metal plates, which may slightly reduce overall energy efficiency compared to fully adhered systems. TPO, EPDM, PVC, and modified bitumen can each be installed using a mechanically fastened system and execution. However, modified bitumen is rare installed in this manner, and fully adhered systems for it are preferred. 3. Torch down or heat welded, used for modified bitumen and some single-ply systems. Torch down roofing creates a strong, seamless bond between membrane layers, resulting in a highly durable and watertight flat roof system. However, this method requires the use of an open flame, which means it must be performed by trained professionals to ensure safety and prevent fire hazards during installation. Heat welding uses specialized tools, including a hot air welder or robotic welding machine, to fuse overlapping seams of single-ply membranes such as TPO or PVC. The process involves directing controlled heat between the layers until the material softens, then pressing them together with a roller to form a seamless, watertight bond. You should also be aware of a product modification for TPO, EPDM, and PVC, which is also available. These products can be available in what is called fleeceback. Fleeceback roofing is a type of single-ply membrane which has a fabric or felt-like fleece layer laminated to the underside. This fleece layer provides extra cushioning, strength, and adhesion surface, allowing the membrane to be installed over rough or existing roof surfaces using low-rise foam adhesives instead of traditional glue or fasteners. Fleeceback systems are especially popular for roof recover projects as they help smooth out minor deck imperfections, improve impact resistance, and offer additional thermal and sound insulation while maintaining the durability and flexibility of the base membrane. Every flat roof assembly is built from the bottom up. Substrate, usually with decking or metal decking. Vapor barrier helps control moisture movement. Insulation board, commonly polyiso, chosen for its higher value. Cover board, such as dense deck or fiberboard. Lastly, the membrane is installed to the top of the assembly. In the case of modified bitumen, a base sheet is first installed before the cap sheet. The cap sheet is the granuled layer exposed to the elements. To have a better understanding of the layers and accessories of a flat roof system, let's go over the purposes of some of the layers, as well as some of the other seam and flashing accessories required for a finished and warrantable roof system. Polyiso insulation boards provide high thermal resistance, or R value, which measures how well the material resists heat flow. The higher the R value, the better the energy efficiency. Roofers often mix insulation thicknesses, such as 1.5-inch and 2-inch boards, to achieve the required R value in slope design. Cover boards like dense deck and fiberboard protect the insulation from damage and create a smooth surface for adhesion. Dense deck is denser and works well with fully adhered systems. Fiberboard is lightweight and budget-friendly, but may not perform as well under torch down or solvent-based adhesives. A parapet wall is the vertical extension of a wall above the roofline. Flat roofs are usually installed up and over parapets, then capped off with coping metal to prevent water intrusion. If no parapet exists, roofers must either build one up to meet local code or use an accessory called a gravel stop, which prevents water from rolling over the edge. In some cases, a custom gravel stop must be fabricated to meet the specific code height requirements. Flat roof systems include numerous accessories that complete the waterproofing assembly. A proper pipe jack boot is essential for keeping a flat roof watertight around pipe penetrations. It flexes with the roof membrane to prevent cracking and seals tightly to stop leaks. Using the correct material, TPO, PVC, or EPDM, ensures a secure bond and protects the roof deck from moisture damage and costly repairs. T-joints. Proper T-joint treatment is crucial because it seals the intersection where three membrane sheets overlap, a common weak point for leaks. Applying a T-joint patch ensures a smooth, watertight seal that prevents water from pooling or seeping through seams. Seal strips. Seal strips protect fastener lines and exposed seams on mechanically fastened roofs. They cover screw rows to block moisture and UV exposure, improving wind resistance and extending the roof's overall lifespan. A termination bar is important because it securely anchors the top edge of a roof membrane where it ends against a wall, parapet, or vertical surface. It keeps the membrane from pulling loose over time and prevents water from getting behind the system. When sealed properly along the top edge, the termination bar ensures a tight, watertight finish, protecting vulnerable transitions and extending the life of the entire flat roof system. Adhesives and sealants are essential for bonding roof components together, such as membranes, insulation, and coverboards. They create a smooth, secure surface without mechanical fasteners, helping improve wind resistance and waterproofing. Using the right adhesive, whether solvent-based, water-based, or low-rise foam, ensures proper adhesion and long-term performance under changing temperatures. A vapor barrier is vital in flat roof construction because it prevents warm, moist indoor air from migrating upward and condensing beneath the roofing system. Installed directly over the roof deck, it protects insulation and structural components from moisture damage, mold growth, and loss of thermal efficiency. By controlling condensation, a properly installed vapor barrier helps maintain the roof's long-term durability and energy performance, especially in climates with wide temperature swings like those in the St. Louis region. Proper drainage components are essential for keeping flat roofs free of standing water. Drains are installed at the roof's low points to funnel water into the internal plumbing system. Scuppers allow water to exit through parapet walls, serving as either primary or overflow drainage points. Collector boxes, mounted outside the wall, catch water from scuppers and direct it into downspouts or gutter systems. Together, these components ensure efficient water removal, prevent ponding, and protect the roof membrane and structure from premature deterioration. Even though we often call them flat roofs, a truly flat roof would hold water indefinitely. Standing water leads to premature membrane breakdown, leaks, and even structural damage over time. That's where tapered insulation systems come in. A tapered system is designed to create positive slope, guiding water toward designated drainage points, like internal drains, scuppers, or gutters, so that no water remains on the roof surface for more than 48 hours, as required by building code. Most tapered systems use polyiso insulation boards that are precision cut into angled sections, usually 4 feet by 4 feet. Each panel increases or decreases in thickness to form a gentle slope across the roof surface. The slope is typically designed between 1/8 inch to 1/4 inch per foot, depending on building code, roof size, and drainage layout. 1/8 inch per foot is the minimum slope permitted by most commercial roofing codes. 1/4 inch per foot provides faster drainage and is often used in high rainfall areas or complex roof designs. Material options. There are two main materials used for tapered systems: polyiso and EPS, expanded polystyrene. Polyiso is the most common choice because of its high R value per inch. It's lightweight, easy to cut, and integrates seamlessly with other roof insulation layers. EPS, on the other hand, is more affordable and ideal for creating complex slopes or large fill sections. It's made from the same type of foam used in coffee cups, giving it excellent dimensional stability and resistance to moisture absorption. However, EPS is more chemically sensitive. Many solvent-based adhesives can eat through it. Engineers or roofing manufacturers can assist in creating a taper layout plan that meets both slope and insulation value requirements. Flat roofs can be fully removed and replaced, but in some cases, an overlay installation is a cost-effective option. If the existing structure is sound, installers can add a new coverboard, membrane, and accessories over the old system. However, factors such as door thresholds, rooftop patios, or HVAC curb heights may make overlays impossible. Always consult your production manager or leadership team before recommending this to a client. Flat roof systems are a vital part of commercial and multifamily roofing in the St. Louis area. As a sales professional, your goal is to educate property owners about their options, benefits, and code compliance. If you're ever unsure about the technical requirements, consult your leadership team. And remember, accurate information builds credibility and trust with your clients.